Hello my dear students, welcome back to NEET World. So we will be discussing the previous year questions of JEE, NEET and EAP set in this particular session here. Okay, so now here the first question we have from EAP set. The question says the E naught value of cerium plus 4,2 plus 3. The reduction potential of cerium is given as 1.6 and iron is also given. Then they are asking what is the E naught of Fe plus 3 oxidizing Ce plus 3. It means what? E naught cell, I can write E naught cell equals to E naught of Fe plus 3 is oxidizing Ce plus 3, right? It means Fe plus 3 should undergo reduction, Fe plus 3 to Fe plus 2 plus E naught of Ce should be undergo oxidation, okay? Ce plus 3 to Ce plus 4. That's it now? Yeah. So that's it. This is what the question they have mentioned here. Right now this is repeated twice in the exam. Okay, or similar kind of questions will be seen in the JEE, NEET and EAP set. Okay, yes, look at here. So take the values they have mentioned. So for reduction of Fe plus 3 to Fe plus 2, how much it is? 0.76 moles plus what about reduction, like this is undergoing oxidation, but they have mentioned reduction potential value. So opposite of this value will be, the negative of this value will be oxidation potential. So that is nothing but minus 1.6 moles. So therefore by simplifying this, what we will get? Minus 1.6 plus 0.76 right now. So this gives you minus 0.84 moles. Right now this will be the answer for this particular question. We have here option number 2 as your answer for this particular question, right? Yeah, is this clear or not? Yes. See, this is a very generalized question, like very common questions we will be seeing in the exams, like giving the reduction potential and asking what is the E naught standard reduction potential of the cell. Okay, this is one type of question, and other type is by giving the reduction potential values, they will ask which is strong reducing agent, which is strong oxidizing agent. Okay, so just look at the values. See, the reduction potential of explanation for this particular question is over. I am giving just extra information. See, the reduction potentials of two half cells are given here. So now the one which is having more reduction potential will undergo reduction easily. So cerium plus 4,2 plus 3 having more reduction potential now, so it will undergo reduction easily and oxidizes others. Okay, so I can say this is a strong oxidizing agent because it is having reduction potential easy more now, so more reduction potential, easy to undergo reduction and oxidizes others. Okay, like that. Okay, so they will ask by giving the values which are the following is a strong oxidizing agent, or which are the following have more reducing power or oxidizing power. This type of questions we will be seeing in the exams on this particular topic. Okay, next here we have from electrochemistry, says that the del M of acetic acid, like molar conductivity of acetic acid with concentration C represents which of these graphs. Okay, so they are saying the molar conductivity del M of acetic acid and taken on y-axis and concentration is taken on x-axis here. Okay, so what is a graph represents exactly that particular change here. See, so we have a weak electrolyte, acetic acid is a weak electrolyte now. So what happens here is, so as you dilute the solution, number of like dissociation takes place, therefore number of ions will increases, so at lower concentration, it means upon dilution degree of dissociation increases, therefore its conductivity also increases as number of ions is increasing right now. So at lower concentration you have, see here, yeah, so that is what we have studied in Ostwald's dilution principle. But here you can see the graph here represents, see, so it represents something like this. See, as concentration increasing, see the molar conductance is increasing as number of ions increases here. See, this line does not meeting any of this point on the y-axis, so because the dissociation will not take 100% now, therefore there is an equilibrium reaction between ions, undissociated molecules and the dissociated ions, but 100% dissociation won't take, therefore this line never touches, this curve never touches on this y-axis. So this is a suitable graph that indicates del M, molar conductance versus concentration of weak electrolytes. Okay, so now for this, how can we calculate limiting molar conductance? Limiting molar conductance. It means what? Limiting molar conductance means, see, this side if we go, what happens to the concentration? Concentration decreases now. If concentration decreases as we go this side, concentration increases. So if I say this is 0, it means concentration will be 0. At 0 concentration, it means at infinite dilution, what is the limiting molar conductance? They will ask. That is what is the conductance of that particular electrolyte. We can call that limiting molar conductance. So for weak electrolyte we cannot calculate by the graph, but for strong electrolytes we can calculate. So for weak electrolytes we can do this using Kohlrausch law. What is that? Kohlrausch law of independent migration of ions. Using that technique we can calculate, but not from the graphs. Okay, remember this point. Okay, next look at this question we have. Yeah, the nitrogen can be estimated by Geldahl's method for which are the following compound. See, there are 4 organic compounds. So for which compound we can use Geldahl methods to calculate the quantity of nitrogen present in the given compound. Okay, this is a quantitative analysis. Right now, see, in Geldahl's method we will digest the given organic compound so that the nitrogen present here converts into ammonium salts. Right now, so here the nitro group we have, and here nitrogen present in the cyclic ring. Right now, and this is like diazonium salt here we have. Okay, so remember Geldahl's method will be useful when the nitrogen atom is set free like this. Okay, whenever it is in nitro form, already maximum oxidation state, it's already oxidized, and this is in a stable ring right now, so this won't comes out in the digestion process. And this N2 gas, whenever you heat this in the during digestion, if you heat this, N2 gas will be liberated out, therefore there is no nitrogen present here. So but what we require, it should form this ammonium salts. Okay, for that purpose this N2 gas will goes out, that won't form ammonium gas. So we cannot estimate for nitro compounds and nitrogen present within the ring, that cannot be estimated using Geldahl's method. And one more is, if it is present in this diazonium salt manner, like N2 manner, N2 plus like this. Okay, so you cannot able to find in A, C, D, but you can find if nitrogen is set free like this amine group. Okay, so here this is the only compound you can able to find out of the 4 using this Geldahl's method. What is the quantity of nitrogen present? Okay, yes. Okay, next let us move forward with few more questions. Yeah, look at this. During the action of enzyme zymase, glucose is converted into dash with the liberation of carbon dioxide. See, glucose converts into ethanol when you use this enzyme zymase here. So glucose converts into what? Ethanol. ETOH I am writing. So ethanol, just remember what is the catalyst here we are using, zymase, you can remember. Okay, yeah. Next, what about this simple reaction? See, this is also asked in last year 2024 shift 2 paper. So just look at the question, what they are saying. The given types of reactions this side, and the examples are given here. Just match them. Okay, simple question from redox reactions I can say. Yeah, so try to match it. Try to match this. See, in the first option what it is happening here, N2 plus O2 combining to form 2NO. So I can say this is a combination reaction right now. So A4 here we have. So A4. See, in option D we have A4. Only option which is having A4 is option D. So that will be your answer. That will be your answer for this particular question. See, and you can also verify with other options. B1. So here this lead nitrate PbNO3 tries undergoing decomposition forming O2 gas and 2PbO and NO2. I can say B1. Okay, it is undergoing decomposition, so B1 it is correct. Yeah. So next one is here 2Na reacting with water and displacing hydrogen gas from this water right now. So I can say this is displacement reaction C2. Yes, C2 we have, therefore in D3 which is undergoing disproportionation. Here N nitrogen is in +4 oxidation state. In the product side you have +3 and +5. So it means same element undergoing reduction as well as oxidation. So starting material is having +4, it is converting into +3 oxidation state. and also plus 5 oxidation state. It means what I can say, undergoing reduction and also undergoing oxidation. So this is the best example of disproportionation reaction. So D3. So option 4 will be your answer for this particular question, right? Yeah, let us move forward with few more questions here. Yeah, look at this. This is from solutions related to osmotic pressure. So just look at the question. I will give you the hint, you can able to solve this. See, x grams of magnesium sulfate in 2.5 liters of solution has osmotic pressure of this much, okay, at 27 degrees Celsius. What is the value of x in grams? Okay, so they are asking what is the MgSO4 taken in this solution. Okay, by looking at the osmotic pressure and other data given, we need to answer this. See, osmotic pressure pi is equals to I, Van Hoff factor of that electrolyte, into molar concentration into S into T. So you can write S or you can write R. Okay, so you need to find this molarity, or instead you can find I into, so this molarity I can write number of moles as weight of solute, okay, and molar mass of solute into what is the volume they mentioned, 1 by V, that volume here you take liters, okay, and S value you can say 0.082 because they are given it is in ATM, so 0.02 liter ATM Kelvin inverse mole inverse multiplied with temperature as 300 Kelvin, that's it. Okay, so what is the pi value they mentioned, 2.463, okay, so ATMs. And here what is the molar mass of this particular MgSO4, it is 120, like 24 for magnesium, 24 for magnesium, sulfur 32 and 64 for oxygens, 4 oxygens. So this will be how much? So this will be 120. Okay, just check, yeah, it is 120. So you can take molar mass as 120. And what about the volume here? 2.5 liters. So take volume here 2.5 liters. Okay, that's it. See, and what about I value mentioned in the question? So it is mentioned just 1.8. So take here 1.8. Okay, that's it. So except this weight of solute, that is what we need to find. Every other data is given right now, so you just need to simplify this, then you are getting an answer like weight of solute here will be 16.6 grams. Okay, this will be your answer for the question. Okay, so just simplify this, you are going to get this answer. Okay, right. Okay, let us move forward with few more questions. Yeah, so look at this. For the following radicals, the correct order of their stabilities is, okay, so tell me what is the order of stabilities for radicals. See, carbon radical, like here free radicals given are different types, like they have given primary, secondary and tertiary radicals are given. So now which is more stable? So we know free radicals are stabilized by mesomeric effect, inductive effect and more effectively by hyperconjugation right now. So now hyperconjugations will be taking place when there are more number of alpha hydrogens. Just look at here, how many alpha hydrogens are there? 3 this side and 4, 5 and here 6, like that. And this is the carbon which is tertiary, the free radical carbon is tertiary in the first case, and here it is primary, okay, and here it is tertiary again. So the here 2 hydrogens, here 2 hydrogens, 4 and here 1, 5 hydrogens, 5 alpha hydrogens are there. And for this is 2 hydrogens and 3, this is secondary with 3 alpha hydrogens. Like this you check, more the number of alpha hydrogens, more is the stability. So where do we have more number of alpha hydrogen? In case 1 we have almost 6 alpha hydrogens and all the sides are alkyl groups are stabilizing. So 3 plus I groups and 6 hyperconjugations are possible in the first case. Okay, so I can say maximum stability is for A. Okay, and after that, see here you have 5 alpha hydrogens and from all the sides it is a tertiary, therefore that is also stabilized by what? 3 alkyl groups. So next AD, okay, next AD. After this here you have secondary and primary. So simply you can just go with this secondary, tertiary, primary. This is the stability order of carbocations and free radicals right now. Yes, so this is general order. Based on this AD we got, and after that we can see put C because it is secondary, which is more stabilized than primary. So B. Okay, AD, CB. So option C will be your answer, having D, A, D, C, B So which is more stable here? A is more stable compound here, right? Yeah. So let us move forward with few more questions again. Yeah. So look at these. This is a question from equilibrium saying that, so ferric chloride Fe plus 3 is given, okay, Fe plus 3 is given, okay, this is how much? 3.1 mole of Fe plus 3, and ammonium cyanate is given, thiocyanate is given, SCN minus, so SCN minus is given, so this is of 3.2 molar is given, and when these two are combining, they are forming Fe SCN plus 2. Okay. So now see, as per the equation, we have 1 mole of this Fe plus 3 and 1 mole of SCN minus forming 1 mole of this product, right now. So this is as per the stoichiometry of the given reaction. So now what is the data given? 3.1, 3.2, okay. So now at equilibrium, it means during the reaction at a time t0, initially there is no product formation, but after some time t, when it reached equilibrium, they are saying some amount of SCN plus 2 is formed. What is that amount? 3 moles is formed. So 3 moles is formed here. So this is nothing but, see, in order to form this product, some amount of reactants has to combine now. So I am writing that 3.1 minus x amount is converted into product side, and 3.2 minus x, so x amount is converted into product now. So what is the percent, like x amount, that is given as 3.0. So now what we have here? 3.1 minus x, that is nothing but 3.1 minus 3.0, that is 0.1 of Fe plus 3 is remaining, and 0.2 of SCN minus is remaining, and what is the product here formed? 3.0. These are the molarities or concentrations or number of moles remaining or having at the equilibrium condition. Now find the equilibrium Kc value. So how can you find this Kc? Kc equals to concentration of product, that is how much? Fe SCN plus 2, okay, whatever stoichiometric coefficient 1 is there now, so you can write here power 1, if it is 2, write as 2, okay, and then next here Fe plus 3 and concentration of SCN minus, that's it. Okay, just substitute the values, you will get the answer. So this is 3 here, and here you have 0.1 for Fe plus 3, and for SCN it is 0.2. Okay, so I can write this as 300 by 2, so which is 150. So what is your answer for this particular question? Your answer will be what? Option number 4, which is 150. Simple right now. Yeah. So first of all, you need to solve some basic questions if you are facing difficulty with any chapters, and you can go through the PYQs or any other like higher level questions. First start with very basic if you are really struggling with any chapter, like most of the people will suffer with equilibrium right now. So solve the basic questions, understand the concept and get some confidence, then go for the next level questions. Okay, yes. Okay, next here we have, yeah, look at this. Look at this. This is the compound given and treated with Br2 in presence of iron. Okay, so what is the product formed here? So what is the product formed here? Just look into the question once again. Yeah. So what happens here when bromine is added to iron? So it generates an electrophile like Br plus right now. So this Br plus is a reactive species with this substrate given. Okay, so where it will react, where this electrophile will be directed in the given substrate, that will be the question asked here. Okay, so look at here, we have nitrogen lone pairs here which is attached with this phenyl group, and this side carbonyl group is attached to this phenyl group carbon. Okay, we know this carbonyl group is electron withdrawing groups, and that will drag the electrons from the ring and makes this phenyl ring as electron deficient right now. So but in the other case, this beside ring, if you consider, so what happens here, you tell me what happens here? The lone pair electrons of nitrogen will take part in the bond, like in the conjugation with the ring electrons, and makes it is more electron density right now. It means it creates like more electron density in the ring, makes negative charge, so that this is electron deficient and we have more electron density in this particular ring, and directs the this group directs the electrophile either ortho position or para position. Since we have ortho substituted, therefore this group will goes to the para position here. Okay, so the electrophilic substitution takes place at the para position to that nitrogen atom. Okay, so write the remaining thing as it is. Okay, I am writing as it is, and here nitrogen lone pair, like this we have now. Since this is electron directing electron donating group directs the nucleophile to this position, you can write Br here. That's it. This is a simple reaction, so you have option B as your answer. This is a JEE advanced question some years back. Okay, very simple now, right? Yes. If this is clear, just click on the like button. Okay, and I will give you one sample and a simple exercise kind of question here. So just tell me the product in the options. See, I am writing here electron releasing group, I am writing here electron withdrawing group. Okay, so now if I want to add one electrophile, so electrophile goes to which position? So I am writing here 1, 2, 3, 4. So which position this electrophile will be directed? Okay, or where it is substituted? Okay, so just tell me your answer in the comment box, either 1, 2, 3 or 4 position. Okay, so based on your understanding you should answer this. Okay, now if the same reaction is done with the nucleophile, where this nucleophile will be directed into this position, into which position it is directed? So tell me, electrophile directs into some positions like you can say 3, 2, 1, 4, whatever you are expecting, any one option you put here and here also. In the comment box I will be looking into it. Okay, yes, feel free to answer. Okay, even if it is wrong, no issues, I will help you to do. Okay, so now I have explained you iron compound, that iron complex formation, Fe+3 and SCN minus. So like similar concept, use and solve this question. Okay, this is as a practice purpose, and tell me your answer in the comment box. Okay, and next question, look at here, this is from effect of temperature and equilibrium constant. Okay, from Le Chatelier principle I can say. Okay, for the given reaction, this is a given reaction, Kc value is 66.9 at 350 Kelvin, okay, 350 degrees, and Kc equilibrium constant is 50 at a temperature 448 degrees. So now what happening here? So temperature is rising from 350 to 448 degrees right now. So what about its equilibrium constant value also changing, but what about its value? With rise in temperature, equilibrium constant value is decreasing right now. So it means see, more is the equilibrium constant value, I can say more is the forward reaction taking place. But what happens with the rise in temperature, equilibrium constant value is decreasing right now. It means forward reaction, if temperature is raised, its Kc value, if T is raised, Kc value is decreasing. It means what? This is an exothermic reaction. Why I am saying exothermic reaction? So in exothermic reaction, the forward direction is favored by low temperatures. Okay, for that reactions, if you increase the temperature, it will move backward, not the forward. Okay, so for a particular reaction which is in equilibrium, if I write like this, okay, this side forward and this side backward we are discussing right now. So B here I am writing, A here I am writing. Okay, so if forward reaction, if B side is exothermic and A side is see, if I say B side is exothermic, the reverse reaction will be endothermic. It means the reversible, it means what? A side will be endothermic, so opposite it will be. Okay, so with a rise in temperature, see, this side is an exothermic, that's why with rise in temperature, what happens to the equilibrium constant value? Getting decreased. So I can say this reaction is an example of exothermic reaction by looking at the values. So exothermic reaction delta H is negative. So option 2 will be your answer for the question, right? Yeah, hope this is clear, right? It means what happening here? So with rise in temperature, equilibrium going backward, it means backward, like reactants H2 and I2 formation is taking place, not the HI, as we increase the temperature. This is what you need to remember here, favoring towards reactant side. Okay, next look at this question. Look at this question. So pH of 0.02 molar ammonium chloride, how much they are asking? Yeah, so how you will be solving this question, tell me? Yeah, so look at this, pH of 0.02 molar ammonium chloride solution will be very easy. Ammonium chloride, how this is a salt, right? So this salt is formed from ammonium hydroxide and HCl. Right now it means a weak base, a strong acid is used to form this particular salt. Right now upon hydrolysis, it means salt hydrolysis, what you are going to get, see, just take this salt and keep in the water, what you are going to get, ammonium hydroxide will get and HCl, acid is formed. So see here, Cl minus, I can remove these strong ions, like ions coming from strong electrolytes. Okay, we have only H plus ion here. Okay, so ammonium hydroxide, like ammonium chloride undergoing hydrolysis to form H plus ion, therefore resultant solution will be what, acidic solution, because this is a weak base, so resultant solution will be acidic solution. Right now, so it means pH definitely less than 7. Okay, less than 7, but how much exactly? Okay, for that you just use this formula, pH equals to 7, less than 7 or 7 minus half into, here we have what we have here, weak base. Now it has base dissociation constant Kb, so take half into pKb plus log C. Okay, this will be the formula you need to use. Okay, so just look at here, Kb value is given as 10 power minus 5. Okay, so pKb will be what, pKb equals to minus log Kb. Okay, so it means minus log 10 power 5. Okay, it means what you will get, so 5 will be your pKb is 5. Okay, so just substitute here, pKb is 5 and log C, what is the concentration mentioned, 10 power 2 into 10 power minus 2. So put the values here and you will get some answer from these 4 options. Tell me in the comment box what is your suitable answer. This is again JEE mains question. Okay, yeah, I am expecting answers for these like small questions from your side. So just try this and tell me in the comment box. I have helped with all the concept here. Right now, yeah. So thanks for watching. So stay connected with this NEET World channel, and if you have any queries or anything that is not clear in this particular session or any topic that you are facing difficulty during your preparation, write in the comment box, and if you are new to this channel, just click on the subscribe button and you can share with your friends. Thank you.